We are live. Am I correct?
Yes.
Yes. Awesome. Amazing. Welcome everyone who's watching us today. We're going to have an exciting workshop of a special series of workshops that we have had. Actually, it's one of the most unique kind of contents that I personally have seen for Web3 developers that are actually, wanting to learn about DeFi, but deeply. So first of all, I just want to say thank you, Billy Jitsu, for doing this with us. And I hope that our developers on Metis L2 really take advantage of this unique opportunity.
Thank you. Thank
So
you. I don't know if Needy wants to make an intro.
yeah,
Yeah.
Nidhi, go ahead. How
Yeah,
are you?
I'm good. I'm good. Going good. People have been saying me with the villages for last many workshops. So those who don't know me, I'm the Nidin Akroni Devral from the my side, and yeah, we will be covering all the topics that we have been seeing till now for the API3 and in all the integrations of API3 and Marys on this particular workshop. So, as it says that putting all together, flash loans, liquidations with API3. Um, I'm particularly very excited for this workshops, and let's see.
Yes. Yeah. I'm going to go ahead and put up my presentation. As I'm doing that, I'll tell you who I am. For those that are just catching in today, I am Billy. I DevRel for API3. We saw, well, I saw a thing like there's not enough DeFi being taught, right? We have very basic information about DeFi, like how to do a basic swap or how to do a deposit, but no one takes you through the whole flow of like, oh, here's a flash loan, what to do with that flash loan, how to interface it with your flash loan, what can you do with it, right? We always see a lot of net negative stuff, but there's a lot of opportunity on that, right? And again, we are an Oracle solution. For those that don't know what API3 is, we do price feeds, right? Like a lot of oracles do. But one thing that we do have is we have this OEV solution where dApps can actually generate money by just using our oracle, right? And I'm going to explain that all in the workshop today. So let's go ahead and like jump into it because it's a lot of information. We've done 6
Yes.
workshops previously, step by step, getting you through the whole thing. And so we'll just cover that really quick. For those that want to have direct access to me, ask me questions. I've been actually getting a lot of questions about stuff in the workshops, which is really great. I'm also in the Metis Telegram channel. Just ping me at Billy Jitsu. But this is my Twitter. If you like half sarcasm, half technical, I'm the guy for you. So, reach out. I'm pretty available. So the first workshop, just to kind of go through it back, we did the fundamentals of API3, like how price feeds work, how to get into your smart contract. We did it in our remix that is available on the Menace YouTube, right? We also learned how to use adapters for your code. If you're a hacker or builder, or you're forking some code, right? And you don't want to refactor the entire code base to use API3 workshops, well, you can use an adapter. And with the latest update, you can actually use API3 adapters right out of the box with like V3 interfaces and stuff. So, we make it as simple as possible for you to use, and then we also show you how to use the marketplace. The second workshop was Oracle Extractable Value, what really kind of sets API3 apart. We did the white paper of that, of like basically instead of MEV on validators, you're kind of doing a little bit of MEV on the Oracle solution itself, right? So understanding how push oracles work, how pull oracles work, and then how we actually use the OEV network to update an oracle in real time. The third workshop, we broke it up into 3 pieces. It's a lot of work. So we actually deployed a borrow lending dApp. So we forked Aave, we built a CLI tool, and I showed you how to deploy that. What you learned was like how to create assets, how to deposit, the terminology of collateral versus debt. Basically, look at what your position health factor is, and how profits work. And then we actually liquidated, right? We used OEV to liquidate position. We did that with an EOA wallet, right? Very simple way to do it. Like if you had some money in your wallet and you wanted to liquidate a position, you can do a call. Not everybody has money in their wallet, right? Like I don't have $3 million to pay back a loan and make money. I wish I did, right? So then the fourth workshop series that we did flash loans, understanding how flash loans work. So you can borrow the money for a block as much as you need, as long as the liquidity is there. And we did it based on Aave V2 and V3 and with another tool called Tenderly. So you can see how you can simulate it. And then we did a liquidation with that. So actually we just did a flash loan. So today we're going to do a liquidation with all 3 previous workshops, like understanding OEV. We want to update the Oracle. We see this position. We want to liquidate this position, but we don't have any money. So we're going to borrow money off the platform to pay back the loan. swap our profits, and then, walk away with the profit. So that's the due prudential of OEV. So today we're going to perform a flash loan and liquidation with OEV. There are 2 repos in this. I shared it with Needy. If you can share it in the comments as well, as to you already did. The liquidation that we're going to do is going to be based on our fork of what we did of Aave. So I don't like doing things in script where it's just simulation, because you don't get to see it. You don't get to see it in the block explorer, especially for learning. When you're doing it for high speed, definitely, and we want to save testnet tokens. But I'm going to be using that Aave fork as a reference, and then those references are going to be in our liquidator, right? In most cases, your liquidator, your repo is going to be not a fork of Aave. You're going to have your own liquidation repo, and you're going to reference some of the oracles or some of the APIs in whatever platform you're liquidating. So we're working off 2 repos, but I'll be demoing both. So workshop breakdown today is we're going to review everything we learned, how OEV works, how flash loans and liquidations work, right? And then we're going to put it all together. We're going to review the final contract of my liquidation smart contract. And then we're going to go through the script flow. Like, how do I call the script? What is the logic before I call the script? And then how do I prepare that?
So I have a quick question before we go deep into the workshop, which is, let's imagine I'm a new developer, right? And I'm just stopping by this video for the first time, and I'm
Yep.
like, wow, blown away by all the things that I can learn from this. So in terms of what I need for my setup, what do I can we tell them, like, in general, what do you need? Like, if this is the first time that you are checking out this video, you're maybe just getting started with Solidity, what do you need to have installed in your computer? What are their main resources? That kind of thing.
Definitely. So like, if the beauty of it is that we have this all shit saved on the Metis YouTube page. So like, if you go to the Metis and you go /Metis API3, you'll see all the workshop we've done together from starting 1. So if you go back to the Oracle workshop 1, all you need is Remix, right? You don't even need an IDE to get it going. You can just play with a smart contract. As long as you have a little bit of testnet tokens and Remix and a website, you can play with it all day long. As we start getting into the second workshop, you have the IDE. So you need like a VS Code, or what is that AI agent one? Cursor, yeah, or any other ones. You can totally use that. And we all have repos. What I do as a DevRel, as my own personal frustrations, is you can actually fork every one of those workshops into a local code. There is a repo for you to fork, so you don't have to rebuild it. So you can fork it, play with it, make sure it works, and then you can adjust your numbers or tinker with the repo. That way you're not like trying to build it from like a docs kind of thing, right? Like, I just literally copy and paste, fork, download the updates, and they're all explainers in the README of like yarn install. And then you can just start messing around with it as long as you have the tokens already set, ready to go. So start from YouTube series number 1, and then work your way all the way through the 6 workshops until we get to this one.
Amazing. Thanks so much.
Of course. So yes, basically coming back to liquidations, if you haven't referenced it, liquidations basically occur in this sequence in order for anything to happen. So the first thing that has to happen is the Oracle update, right? So if the price of ETH is 2,000, everybody's fine until the price changes, right? And then the Oracle updates, then your health factor changes, right? So if you have a debt position, if you were longing ETH 3 weeks ago, what, you weren't in a good position, right? Your health factor was dropping because the ETH value was dropping, right? As that value is dropping, searchers see those positions like, hey, this guy is going to get liquidated, right? And so then everybody bids for that transaction to go through, right? Everybody here in the workshop, anybody that watching in the series, they all want that liquidation because there's money to be made, 5 to 10% profit, right? So we're all spamming the Metis, sequencer and say, hey, I want my transaction to go through. So like, if you look at like Dune Analytics and you check, at any liquidation point, how much spam is happening at any given time, do it during liquidation events, and you'll see 30 transactions coming from the same wallet to get that one thing. And you'll see it from like 50 different wallets, right? And then eventually one of those transactions goes through, and then the user gets liquidated, searcher, gets their money, and then, they're happy, right? But the main point is, with the power of OEV, you can control when the Oracle updates to a certain extent, right? So then you don't have to fight for this, because you can update it and then atomically update the price feed and your transaction at the same time. So just bringing it back to the liquidation factor, right? The most important thing as a liquidator is you're going to be watching health factors of every wallet out there, right? So the value of your collateral, the value of your deposit, let's say my ETH, right? times the liquidation threshold. If you check the docs of Aave, Compound, or any borrow lending app, each asset has a certain liquidation threshold based on their, rep, in a sense, like their how dangerous it could be for that asset. ETH is like 0.75%. They'll liquidate you at 75% of your loan to value. Or wrap BTC, I think it's 70%, USDC is 80%. So each one has a little bit of a different liquidation threshold. If you look at the script of the borrow lending app, you can scan it and see each threshold of each asset listed. And then that's divided by the total value of the debt. So if I deposited, let's say $1,000 of ETH, right? Liquidation threshold is 75%. I borrow $700 of USDC. I'm okay until the value of ETH drops to maybe like 950, 900. And then all of a sudden I'm way higher. And then my health factor is below 1, right? So that's basically for those visual, this is my borrowing capacity, right? I can only borrow so much of my collateral based on the liquidation threshold. So if I put in 1,000, how come I can't borrow 1,000? Because then the platform is not healthy, right? There's no reason to pay it back because you could walk away scot-free. So there is a range of positions. So you're usually putting yourself about 20, 25% position of being able to cash out theoretically of your debts. So just something that we want to like refresh our memory from the previous workshop. So this is the crazy one that scares everybody, but it's really not that bad, is the OEV flow, right? So in a normal mainnet or regular transaction without OEV, you are a searcher, you see an opportunity, you contact the sequencer, and if you win the bid, you liquidate, right? 1, 2, 3, right? But there's so much competition that it doesn't guarantee that you're actually going to get it or not, right? So what we have is a searcher will first on the OEV network is bid on the OEV network. I know this position is going to be, liquidable in this price range, right? And so if I win this bid, I'll have the right to update that price based on that first, image of like updating the Oracle first. If I win, then cool. I get this special signature. I send in the same transaction the ability to update the API3 server Oracle proxy, which is going to update the price feed. In that same transaction call, I'm going to update this price feed and do the liquidation transaction, right? So therefore, it doesn't matter where I am in the block in the sequencer. My transaction is the one that updates the price, therefore lowering the health factor, therefore allowing me to liquidate, right? And nobody can front run me on that because it's the same atomic transaction. And then once I go, do the liquidation transaction, the price feed gets updated, and then I profit, right? And then I win. So that's basically the OEV flow. For those that are a little confused on that, definitely go back to the OEV, the liquidation workshop B, where I go into a little bit more detail about that on there, because there's a lot to cover in the contract. And if you have questions, I'm definitely here to answer. But definitely I go way deeper into this in that section.
No, but that's great because this is the kind of thing that nobody really knows how it works. And remember that when in the past we have been discussing offline about the use of AI agents for
Correct.
this. Is this something that I can just ask in the future, maybe to an AI agent to do for me, so I don't have to go and do all of these things for myself? Or this
Yeah.
is not something I can find a workaround as of now? I remember that you mentioned something about the time
Yeah.
of execution.
Yeah, I personally have done a couple AI DeFi hackathons to experiment with a few things and improve some points. As this is all very speed oriented, right? So like the moment you make a call to an API to an AI agent, someone's already running a script and liquidating, right? Like it's a very speed, like to the millisecond, right? Where people are spamming transactions before you. So if you're spending time letting an AI agent decide for you, you've already lost in this particular case. Liquidations is a very speed focused game, and with OEV, that's what gives you the advantage, right? It's like knowing when the gun's going to fire, when you're going to race. You can feel when the person's going to trigger, so to say. So you can already like get that extra half second before, and that's what gives you the advantage for that. And so what that value is for what people are willing to pay for that is what brings OEV value for that extra advantage. So in essence, for liquidations, AI agents do not help whatsoever because they're too slow. But for watching your position and health factor and paying back the loans based on series, it can, right? So
Okay,
if you,
thanks.
if you want to fork the Aave fork to prove that, right? Because a lot of AI agents can only do certain things on chain, right? You can't do it in simulation, doesn't really show well. You can fork the Aave fork and then prove that. And that's exactly what I did with my AI hackathon, is I could forked Aave. So I had a borrow lending dex and I interacted with it. So you can see what the AI agent actually did to the lending platform.
Gotcha. Perfect. Thank you.
Of course. So OEV. OEV has a certain type of auction system, right? So whenever, for those that trying to familiar back, is our oracles are push oracles. So we're pushing updates on chain every so often, right? Depending on the threshold. So standard on mainnet is like 1% threshold. So if ETH is $2,000 USD, if we were to update that gas transaction on chain every time it changed a penny or a dollar, every oracle would be out of business in like a week, right? It costs so much ETH to update. So what we done is basically within a range of price that's reasonable. So if ETH is $2,000 at a 1% update, the next time it's going to update on chain is either at 1% of 2000 is $20, so 2020, or if the market's going down, 1980, right? So if the price of ETH is 2005 or 1995 on chain, it's still going to be 2020, right? So what happens if there is a liquidation price that I can liquidate somebody at 1995? I can only sit there and watch and hope that the price gets to 1990 and then I can run a liquidation, right? So what we've done is with the Oracle system is we have auctions, right? So there's an auction on every Oracle, on every chain, happening on every feed. So ETH USDC, RAT BTC, Metis.USDC. There's an auction happening every 30 seconds on that to see if somebody wants to bid to update that specific Oracle. So auction one would happen. It would be 25 seconds where everybody does their bids. If they want to, update the Oracle, they can see what's going to happen in 30 seconds, because and I'll go through the script, but you can see what the actual price of the Oracle is going to be in that time for that auction update to update. So everybody bids for 25 seconds, and that 5 seconds time frames, the auction closes, and then the person that won the auction gets their results, right? And so now auction one results are in, auction one winner now can update the price and can liquidate for the next 30 seconds, right? So if we're free falling in a black swan event, I can keep updating and keep liquidating over and over and over for 30 seconds. In the same 30 seconds, another auction has started for that same price feed, where people can say, all right, this guy has it for 30 seconds, or this gal, and then I want to jump on the next 30 seconds because we're free falling. There's opportunities ahead. So they can bid for this. This winner can still bid as well. And then the next 5 seconds, the next winner goes, and then so on and so on, right? So if nobody bids, it's normal Oracle as usual, right? It's doing its regular deviation. But if people are actually bidding and winning, now they're pulling the Oracle. So the Oracle is a bit more precise. So we're not waiting for the $20 range anymore. We can do it to the dollar, to the penny, whatever makes financial sense that's worth the gas, we can do that. So if you win the auction, you can update that specific Oracle as many times as you need for the next 30 seconds. Does that make sense? Yeah. Okay, cool. I know it's a lot of information. That's why I like all 6 workshops combined, right? So the flow of Flashloan, right? So now we won the bid, right? We won the auction. We have the right to update the Oracle. Now there's this thing where I want to borrow $1 million, right? And I don't know how. So just to recap on the Flashloan, there's a lending app, right? Like our fork of Aave, Compound, whoever. They have 4 million tokens of something available to lend out, right? It doesn't work unless they have the liquidity to do it, right? I, as a flash loan contract, I want to borrow $1 million because I see an opportunity and it looks good, right? So I'm going to request in my contract, hey, I want to borrow $1 million. Say, hey, we got 4 million, no problem. Here's $1 million, right? Assuming that you pay it back with the fee, right? Because there's a flash loan fee on this. So I get the $1 million in the contract. My contract then does a bunch of things, right? We're doing liquidations, we're doing the flash loan playback, we're swapping on the decks, right? Because when we get liquidations, we get the other token back, not what we borrowed, right? So if I pay back USDC, I get ETH, right, in return, but I need to pay back USDC, so I have to swap the ETH for USDC on the DEX, and then repay back the loan, right? So that's what's happening in the middle of this flash loan contract. But at the end, I'm paying back my loan, my $1,900,000 tokens, right? Because I have to pay back what I borrowed plus the fee. The rest that I made, that's my profit. That's what I keep. So structure of the contracts, right? If we're looking at our AVE, structure on smart contracts, remember everything is revolving around the lending pool. So everything we interact with is the lending pool contract, right? So like the deposit withdraw for the users, borrow repay, right? There's also flash loan and liquidate. So we're doing all the same transactions all into this lending pool. The lending pool is kind of like the user interface of all things behind the scenes. And then, they have their dEPs, oracles, proxies. Those are all the smart contract stuff making all this happen in the back end, but we only really interact with the lending pool. So what's going to be our liquidator, like our contract going to look like, right? So our script's going to call the OEV parameters first. We're going to say, hey, is this thing liquidable? Can we win the bid, right? We have to make sure that our signature is legit. Like if we're just sending spam transactions, the server's going to say, hey, you didn't win the bid. You can't update the Oracle. Big fail. So we have to make sure that our signature is legit, right? There is something called callbacks. If you looked at the Flashloan contract, you'll notice that when two contracts are talking to each other, I'm going to move in the camera, right? One contract will call something in a function, and then in that same function, it'll call it back to the other contract to make sure that something goes in play. This is how Flashloan works, right? I request, but as soon as I request, there's already a callback at the end of that same function that requires me to pay back. Otherwise, it reverts, right? And it never loans me the money. So it's kind of a safe-ish kind of play. So there's callbacks on OEV payment, right? So you can update the Oracle as long as you pay to update the feed. If you don't pay to update the feed, we revert, right? So we want to make sure that when we call this specific function, and this is on the auction house, that when we call it, it's going to do a callback to make sure that we updated the Oracle and we paid. If we did not, it will revert, and then that transaction's invalid.
And in regards to the fees, is there any way that you can know upfront how much are you going to need to pay?
Oh, for the fee, yeah. Everybody in their
Okay,
docs, yeah, in their docs, it's a standard fee. There are some that have zero fees, depending on where you go. So, depending what's available, depending what is liquid, right? If there's a $10 million liquidation fee, and the one with zero fee has 5 million, pay the fee, right? Whoever has a 10 million. So, yeah. So it's your job as the searcher to have that database of where the zero fees are or the lower fees are. But yeah, that's part of the DeFi game of knowing where it is. Aave is just a great tutorial place because a lot of people look at it. Their fee is 0.09% of whatever you borrow.
Gotcha.
And yeah, and so we're making use of the callback of the OEV payment. So we're in that same callback, and you'll see in the structure of the smart contract, we set up our liquidation and our flash loan parameters. So it's like, all right, we're updating our price feed. As we're updating the price feed, and you're going to check the price to make sure that we've actually updated the price feed. Let's do our liquidation and our flash loan in there before you check that, right? So we're basically structuring our contract flow to follow where the money goes, right? Make sure the money's flowing the way it needs to go. And I'll explain this in the smart contract. I know it's hard to visualize. And then another flash loan. So like flash loans have callbacks, OEV bid payments have callbacks. So we're calling back, back and forth. There's a lot of like contract calling backs. And this is where things get confusing, right? When you see hacks and you start seeing all these transactions happening, these are all callbacks happening back and forth, a lot of things going back and forth. So understanding this flow of like where the callbacks happening is how we understand how our liquidations are. And hopefully I can explain this in the smart contract when you see it. And so that's our smart contract. This is what our script is going to look like, right? Why will we call it? When will we call it, right? So in our script, we're going to look at the median price of what the next auction updated. Remember, we have that 30 seconds to vote, right? So we want to know what's the price going to be in the 30 seconds on there. So we know if we want to bid on it and we can liquidate. So once we know, let's say ETH is going to be 1995, right? If the new price will lower our health factor of our target, we want to play the game, right? Because we can make money. So if we knew that, so we calculate that, like, okay, if the database that I have of all the users, if one price going lower of what I see on that price that's going to be is going to make me money, I want to play, right? So we calculate that beforehand. And then if we win the bid, we want to calculate how much can we pay back from this loan, right? To cover our contract. So in Aave, we know it's about 50% we can pay back from the debt. Compound has like a close factor. So change, crazy places like DYDX, you can do 100% of liquidation. So like, depending on what the actual borrow lending DApp or the perpetual DApp is like, you will need to calculate how much you can pay back on it, right? Because, doing one right now, because I'm doing one single instance is very easy. But when you're doing like 100 different people, you want to, have a script to calculate how much you need to pay back in that time in like seconds, right? You need to know. That's what I'm talking about. This is a speed game. If you're asking AI agent, it's already done. Right? So you have to have the script to calculate, okay, this position is going to go down to this price. What can I pay back and how much money can I make, right? And then once the update is completed, we have to, again, go back to the Oracle and say, hey, we updated the Oracle like we promised we would after winning the bid. And then tell them, all right, so that we don't get slashed on our OEV network. A lot of talking, a lot of presentation. This is the real deal right here. This is where the code is. So it's the same thing that was linked in the chat as well. It's just a QR code to the latest repo on here.
Awesome.
Yeah, I'm gonna leave that up for a second and just kind of like go with a quick overview of here of oops, not that CLI, wrong one. This one here. And so this goes the OEV searcher liquidator, and I just lost the camera here. Let me just add that in back. There we go. So the README hopefully is pretty in depth. It references the Aave fork project that we work off. So I'm working off 2 repos here. Here is the searcher, and then this is the actual Aave fork, right? So when we did it on workshop 3, right, we deployed all the contracts, we saved it to a file, so we have all these deployed contracts that we have as reference on here. So in order for this to work, I've designed it for your own fork on there. So if you're looking at the page, you'll be able to see, you know, where that is. So let me go ahead and do that. So it's going based on your own fork, right? And so there's 3 sections to this, so it's not confusing. One is just perform an OEV update, right? That was workshop 2, right? We just want to update a price feed. The next one that we did was last time is basically how to perform a liquidation on the callback of the price feed. So we were able to do that liquidation with the update price feed in the previous workshop. And so now this next one is perform a flash loan and liquidation. So putting it all together, flash loan OEV liquidation is step 3. So it basically tells you how to build your ENV, because I hate when there's like ENV, oh, like get these random values and they don't tell you where to get it. So here is I'm telling you where to get it. So like this is your 12-word free seed phrase. This is the OEV network RPC. You know, whatever chain you're working on is that RPC. And then lending pool address is from your deployed contract JSON. So you would go over to your deployed contract JSON files and look for the specific, you know, file on here. So you basically have to build all these things because you got to keep track of the price of assets, the Oracle proxies, right? You want to make sure that you know everything that's happening on every part of the borrow lending app and the position. So you're going to be looking at certain aspects of everything on there. So you're going to be making a lot of calls on there. So it does take a bit of work to get that up and running, but once you have it, you have all the details on here ready to go. This last part is the DEX address, right? Like, okay, maybe it's a Uniswap or whatever kind of DEX you have. You want to make sure that you have the address ready to go. Maybe you're using an aggregator to find the best yield. That's going to get super crazy into like finding the best yield for your swap. So I made a simple DEX just to recap on that. It is over here under the liquidations, and I have the contracts. I just have this dex.sol. This is kind of like the most basic version of like Uniswap v1 ever to exist, right? It just deals with token pairs. In order for us to make a win every time I swap, 10%, I always gain 10% when I swap one asset for another, right? So that way I don't like end up negative and the workshop doesn't fail. We can actually make money. We're making money on the swap. All right, so it's just basically a swap between 2 pairs, swapping back and forth. I want to get a preview of what I would get if I swap. If it's a good preview and it looks good, I want to swap the tokens, right? So these are all checks that I want to do before performing the flash loan or while doing the flash loan to make sure I don't revert and then waste gas. So, you know, if you could go back to the previous workshops, you can kind of get a quick idea of how the DEX works. But just to recap, right? If I'm paying back USDC for this position, I need to borrow USDC, right? So when I pay back the loan, I don't get USDC back in return from the liquidation. I'm going to get the collateral that was being used for that liquidation, right? So in our case, I'm using like mock API3 tokens, and another demo, people will say, you're getting ETH, right? So now I have this ETH back, but I can't pay back the loan of USDC that I did for the flash loan. So I have to swap the ETH for USDC so then I can pay back the USDC loans, right? So we have to swap it in a DEX. So this is a very simple DEX on the previous workshop that we want to make sure that we swap the reward we get so we can pay back our loan, right? And be up and running. So that's just a quick review of that entire flow of where you get your actual, you know, data from and where all these things are coming from. So you should be able to rebuild your env file pretty safely. If you still don't get it, DM me, we'll make it work. Right. And so basically it takes you to the steps of everything you have to do: get onto the OEV network, bridge to the OEV network. That was workshop 2. Basically update the price. And so you would be focusing on section 3, right, where we deploy our Flashloan Liquidator contract. Right. We would, for our demonstration, right, I can't control the Oracle price to make sure that it jumps during this 1 hour time where we can actually liquidate. So what I've done is I've made a fake Oracle kind of system. It was actually pretty clever. I'm kind of proud of it. I'm going to say it again. But like in this adapter, I had this mock Oracle, this mock OEV proxy that works on 2 values. One is the actual Oracle value. And then when I use OEV to update it, it's going to use the blog timestamp to let me know that there's another value. So I'm going to set it to a liquidation value. Therefore, when I actually update the Oracle, I'm going to set it to a fake number that I know I can liquidate on, so I can show you how to actually liquidate. Right. So I'm using like fake values, but I'm using the real value first, updating the Oracle to use a fake value with OEV. And then so you can't do this in real life. I'm just doing it for demonstration purposes only. So that's why it says demonstration only. So you're basically funding this fake Oracle in order to use the real asset and then mimic a liquidation if it hit that actual price. Like if the median price would actually be that price. So it'll update it to that. And then you can perform the liquidation on the contract. And then, we put it all together, which we would, submit bid and update and go through the liquidation price. I know that's a lot to swallow, That's why I have it as detailed documented as possible. But let's get into the smart contract so we can all like figure out what this thing does, right? So if we look at it, it's not a big repo, right? We just have the contracts. You'll see that we have sections 1, 2, and 3. The OEV auction house is something that we've done from workshop 2. Make it super simple. It's just a download. So we have the APIs there. The first step 1 was the OEV updater that just updates the price feed. The second one was the last workshop where we did the OEV liquidator, right? Where it just, does the callback here. And then this one is the latest one that we're working on. You'll see it's much more in depth, is the actual Flashloan liquidator. And just looking at the imports, right? We have the ownable because we want to own the contract, because if we do the flash loan and we have the money in there, we want to make sure we don't get front run. We did all the work and then someone just calls our contract to take the money. It sucks. So we have an ownable. So when we get that reward in this contract, only we can take it out, right? And so we have the API3 server extensions, bid payers, which is by default in all the OEVs, right? And then we have this lending pool provider, which is being through the interface. We have our interface for ERC20. So we want to make sure that we have a generic for every token out there, wrap BTC, ETH, whatever token, we have a generic for any token so we can interact with it. And then you'll see that we have this lending pool provider and this flash loan receiver. So these would be the 2 new things that would be on the latest version of step 3. So because we're using Aave Flash V2, I had to update. You'll notice that I'm using Solidity 8, and if you look at Aave V2, it's using Solidity 6. Those don't mesh well, so I had to refactor all these things in Protocol V2. So if you look at the Flashloan stuff and the receiver, you'll see that I refactored it to version 8. It takes away some of the safe math. A lot of the extra stuff on there you don't need, so I've kind of cleaned that up on the interfaces, on the protocol, data types. You'll see that they're all version 8 on there. So they've all been refactored for us to use. So you can fork those and then work that with any version of 8. So just basically a cleanup of any of the old stuff. If you want to reference the old stuff of V6, I got you. So in the contracts of the old repo Aave V2 in liquidations, if you go to the contracts, there is a Flashloan liquidate that uses 612. So if you want to compare and contrast what I did and the difference between those 2, you definitely can. But for time of the workshop, just know that I refactored all these interfaces to V8 and just basically removed all the stuff that we don't need in the version 8 of Solidity. Right? So first thing we want to do is we have this interface for our decks, right? We just want to swap and get the balance, and just let us know that we're looking good. And so I have isownable interface for our bid player and our Flashloan receiver are required. DApp ID, if you don't know what that is, it is for OEV. For every DApp, there's a specific ID that they have in order for us to liquidate that specific one. It's for accounting purposes. So when people, bid to update the Oracle, we know who to pay on there. And so we have the server extension. This is standard. So like any OEV update will have these. And here, this is specific to the Aave. So we have our lending pool. Remember, our lending pool contract is the one that we deposit, withdraw, liquidate, flash loan, right? And then we also need the address provider on here. So the interface for our address provider. And then I just created an object for our DEX. So we have a DEX interface and we want to talk, right? This is built into the system for our OEV payment callback. So you just, copy and paste. You don't have to go too detailed onto that. And then we have a bunch of structures for us for the OEV. Basically, this is the format. Like it's just the framework in order for OEV to work. So we have to pay bid and update our feeds. And basically, this is all the information it needs. Like, did it meet within the 30-second time frame? Is this the correct signature? How much did someone bid? And then all our details of like flash loan, liquidate, all the details that comes in a callback here as well. And then we structure the callback data here. We want our signed data array and our liquidation parameter. So basically the struct within the struct. And then we want to set up our liquidation parameters for our flash loan, right? What's the collateral asset we want? What's the debt asset we're paying? Who are we liquidating? And then how much are we going to pay from that liquidation, right? And then our flash loan parameters. If you've looked at any flash loan tutorial, you'll see that you need the flash loan parameters too. What assets do we want to flash loan? How much of each? What mode? Make sure 0 is no debt, right? So that's for flash loans. And then on the behalf of, we don't really have anything. What are our liquidation parameters? That's where all the juice is for all our cookies. And then the referral code is basically nothing anymore. And then we just throw some events out for our flash loan, like the liquidation executed. You let us know, hey, we got a liquidation. If our bot's running and we went to sleep, we can look at the events on the listener. Hey, I got something running, right? So hopefully I got you so far. Is that good? I'm going to make this bigger. Sorry, I should have made that bigger to begin with. But yeah, I could see the look of like, oh man, hopefully I'm getting there. So
It
in our
forces you to
constructor,
focus more,
yeah,
you need
yeah.
to be really focused, but that's
Yeah,
okay.
it's a lot to swallow, right? Because it's like workshop 1, 2, 3, 4, 5, 6, and now we're putting it all together on there. And that's the tough part. So basically the DAP ID, who are we going to liquidate, right? I'm using DAP ID 1. That's the generic proxy for the marketplace on API3. So if you went to marketplace.api3 right here, this would be here. This is basically all these prices that we would get, that you get off the market. That would be what we would basically be updating. If I wanted to update a specific DAP that was using API3 oracles, I would use their DAP ID that you can find in the docs on there. That's referenced in the docs if there was a specific DAP. And then basically a server extension is our thing on the script already has there, on what chain we're using, what's the address. The lending pool address is our forked Aave that we're using. So if you're using another liquidation point, you want to use their interface for their lending pool. Our address provider is the same thing. What's their address provider for their borrow lending DAP? And then I'm making sure that I actually have a valid DEX address. And then what's the DEX that I want to use? Is it Uniswap or some other kind of like DEX? I want to make sure I have that DEX loaded. So now my contract knows which to interact with, right? I'm using very specific addresses. Maybe as a more professional liquidator, you'll have a generic set of different dexes to choose from to get the best rate to make the most money, right? So if we look at the contracts, let me just minimize these because some of it is kind of review here. There we go here. That way you can kind of see exactly what it looks like here. I know it looks scary, but when you look at it, it's not that bad. So these two, right? The pay bid feed and OEV payment. Remember the callback, right? So when we call back this pay bid fee and update, we're sending in our information. Hey, we won the bid. Here's our signature. Here's how much we want to pay, and then this is the liquidation parameters. This is the first thing that basically feeds through this. So basically, it's saying, hey, these are the parameters that we have. It's going to follow this structure, right? And it's going to make sure that we have the right bid amount, and it's going to look at everything that we have. What did you get the time status? Is this within the 30 seconds? And then what is my callback data? This is where we have all the liquidation and flash loan data, right? It's basically breaking it down. It goes to the auction house, right? That's where we're doing the callback. So like this thing goes to the auction house. We don't know what's happening, right? But at the end of the auction house, it comes back and calls this one the OEV on bid payment, right? And this is where a lot of this magic happens. Is all right, now we know what the bid amount is, and we have all this data, which is still our liquidation parameters and everything here. We are decoding our data, right? So we have that structure of the data that we have. and we want to make sure that we update our data feed, right? We're updating it for DAP ID 1. For this case, we're doing the generic marketplace, and we're making sure that we won the bid, and we want to update the OEV feed. So we're updating the price, right? And so then we're going to go ahead and look at the liquidation parameters that we built in our script. And so say, all right, we've updated the feed. These are our liquidation parameters that we set. Remember, collateral, DAP, how much we want to pay. We want to make sure that this position is actually liquidable once we updated this Oracle, right? We've updated the Oracle. We want to get the user account data from there. So the wallet we want to liquidate, and we want to make sure it goes. If it didn't work and we did our calculations wrong, stop, right? Don't even waste any more gas. Stop the position. We messed up somewhere. We need to go back and refactor our code, right? But we did it right and it works, right? So now we know we can liquidate the position. How much money do we need to borrow, right? So we're going to set up our flash loan parameters, and this is how we would set it up. This is cookie cutter, right? Like you will see every flash loan and it'll look just like this because there's nothing different about it. We're just setting it up for our position. We're doing one asset, so we're only borrowing the 0 position on one asset, how much it is, how much we're going to cover, and then we're going to call that flash loan because we've already calculated how much we're going to pay back. We're going to call the flash loan here. Still within this, on OEV payment, right? Because we've updated the price feed, and now we know that we can liquidate. So like, hey, let's borrow the money, right? And so because we've done this in our script, we're calling our flash loan with all the values that we passed, right? And then in the flash loan, we pause here. We pause here in this moment, and then we go to another callback, right? It goes into the Aave contract, right? Because we say, hey, I want to call the flash loan on the contract over there, right? And then it's going to do all this calculations. It's going to give us the money, and it's going to do stuff, right? So in this flash loan, there's another callback that's called execute operation. This execute flash loan is a standalone one that you can test with a flash loan. So we're just going to ignore it. But like if you wanted just to call the flash loan to test it on your own, you can call this individually without the OEV stuff or anything, just to test it out. But it would call execute operation, right? And so within Aave, it's calling back execute operation. Now that we have the money, what are we going to do with it, right? And so it's like, all right, these are the assets, the amounts. This is everything we've asked for in our liquidation contract. It's going to make sure that we're calling the right lending pool and making sure that this is the contract that called it. And then it's going to decode our liquidation parameters again. So there's a lot of decoding happening back and forth because we can't send array values, right? We have to send them in long strips of hex, or like this long 0x crazy 30 lines of random hex numbers, right? And so what we want to do is we want to make sure that everything we've borrowed from it, we want to approve that token to pay it back, right? So we want to approve the lending pool to say, hey, we're ready to pay back the loan when you're ready to go. And then it's going to do the make sure that we have correct enough balance to pay back the loan. And then now that we have the balance to pay back the loan and we know we can pay it back, we're going to actually liquidate, right? We have the money in our contract. We've approved it to say, hey, we're going to pay you back. We promise. And now we actually do the liquidation call. So now we're calling the lending pool liquidation. We have the money. We know we're going to get this collateral, right? We're going to pay back this. We know exactly how much we're going to pay, and the amount has already been decoded, right? And so now once we get the liquidation, we have our collateral. We get payment back, right? So now we're going to check to make sure that we've actually made money, right? So the initial collateral balance that we had, which was 0, versus what we have now, should be positive, right? And if we're positive, we look good, right? So if we have collateral that we made, we paid back the loan, we got our ETH, or in this case, the mock API3 tokens, we now have this. Let's swap that to pay back our loan, right? So now we call the swap position, right? So if we have more than nothing, we want to make sure that we swap. We're going to approve it first because we have to approve before we do anything, and then we swap. We swap the collateral we got back for the USDC that we borrowed in this case, right? We swap it, we win, and now we go ahead and approve to pay back the flash loan, and then we pay it back, right? And then we come back, right? Because the flash loan completed, the liquidation completed, but our callback has not completed. So we're going to go back up, right? Remember, we came back here, so we end up back here in this position again, and then we pay back what we want to do. Remember, we had a bid to pay back the Oracle. We've already made profit now, so now we have a little extra money. So we had nothing to bid with. Now we have some bid amount. We pay back our bid to the OEV server, and then we say, all right, we did it, and it's complete. So we updated the Oracle. We then requested the flash loan to make sure that we can liquidate. We had the money in the contract. We performed the liquidation, and then we came back and said, all right, we've done everything. Let me pay back what the fee that I required to do the liquidation, and then let everybody know that it was a success, right? A lot of these are just kind of back and forth functions. And then this right here are just things I needed to have if my contract needed to return the address provider and lending pool for the updates. And then now that I've made the money, I need to withdraw my tokens, right? Like the money's sitting in my contract, so I need to pull that money, that profit out. So that's just something I can call an EOA wallet and then call it out. And then the same thing, if I have any ETH, I can just basically pull the ETH back if I got native ETH as a collateral. So in essence, it's just for functions, right? But the functions bounce around a lot, and that's where it gets really confusing. And that's the essence of the callback, right? But it's basically we call this pay fit and update, and it starts a sequence of function calls, right? It calls this, it goes somewhere else, calls this back, and then the Flashloan gets called, and then it executes, and then we do all the liquidations and everything in this execute operation. And at the end of the day, that callback goes back to the original location, and then it finishes off this function, right? So like it's just a non-stop ping pong of calls. This is how it works. This is how it it is. So hopefully that contract makes sense, right? Now we got to do our script, right? Because we got to do a little calculations beforehand. So if you go down to the scripts, you'll see that I have a whole bunch of stuff. Those are step 1, 2, and 3. So the first one, again, if you look at the contracts, step 1 was deploy OEV feed updater, and then the OEV feed liquidator from an EOA, and then the flash liquidator from the smart contract, right? And then there's a few things here. We can deposit collateral. I've already done that already because we want to make sure that our DEX has collateral. We want to make sure that our borrow lending has collateral. So like we want to just deposit all that in beforehand, right? But I'm making sure that you can get it. Like we want to fund our liquidator. That was for this liquidator because we need money in the contract in order to pay. This is right here. Just check the price. I wanted to make sure that my oracle's on there to make sure that it looks good for the demonstration. But what we really need to do right here is the submit, bid, and flash liquidate. So let's take this from the top. This is the script that calls this liquidator contract and does all the calculations for it. You'll see a lot of it has to do with the OEV network and the auctions, but we're just going to go ahead and review it. You'll see that these are based on ethers, and it's the OEV sign data, and I'll explain that all together. And based on your deployment. So when you deploy your flash liquidator, I just have it saved to a local variable so you know where to go. So like it's just yarn deploy flash liquidator, and you'll get your contract address here. So let's go ahead and go to the submit. We know that our auction length is 30 seconds. We know that the bidding phase is 25 seconds, and that we put a little buffer on there. And we know that this is the auction version 1. And for us, we're using DAP ID because it's the generic market, right? And so we just create our providers, right? Building our object for our OEV network. And we want to do it for our target network where we'll be on Metis, right? So we just want to have our objects for those
I have a
networks ready to go. Go
quick
ahead.
question. Yeah, what do you mean by tap ID is set to 1? Like, I didn't understand that part. I
Oh,
mean, can we
sure.
set it to different number, or what does it represent?
So DAP ID goes according to the general market of where it is. So like if I wanted to update a specific Oracle, right? There's certain places for this. I can integrate and I want to update this specific one. Well, whose DAP am I actually updating, right? Like if someone's updating this, and this is probably the worst example. Let me do like wrap BTC, right? So if someone wants to update wrap BTC to this latest one, well, a lot of people use wrap BTC, right? So for OEV to work, you're going to have your own custom wrap BTC feed. And so what is the idea of it? You need to like have a specific ID. What if I wanted to do, somebody forked another version of Aave and then they got DAP ID 27, right? We looked that up on the docs. So if we go into the docs and in the README, you can look at all the different DApps that use the API3 oracles. So as a liquidator, you're going to have that database ready to go. DAP ID is just one. That's the generic market. DAP ID 1 is like every marketplace. Like if I go here, Arbitrum, and I pick a random, I have to switch never. If I'm just go back to like I pick a random one off the marketplace. Every one of these examples is DAP ID 1. This is DAP ID 1. If I go to Metis, DAP ID 1, they're all DAP ID 1 on depending on the chain. If I went to production with this Aave thing, I would not be DAP ID 1. API3 would assign me a DAP ID, and then it would go on their docs. And then say, oh, if you want to liquidate Billy's borrow lending platform, this is DAP ID 43 or whatever. And so you know that when you bid, you're bidding for my specific DAP.
Gotcha.
Yeah.
Thank you.
Of course. So Okay, so we have our objects, right? Basically, are the way that we connect to our JSON RPC. We want to basically create, objects for that so we can interact with our contracts, right? And so we're gonna do our wallets. We have that mnemonic that we're gonna do. So we have our OEV wallet, we have our target network wallet, which is gonna be who we're liquidating. Remember, when I was doing a mnemonic, I was using wallet position 1 to be the liquidator, wallet position 2 to borrow and lend and get liquidable. And then basically what we're going to do is we have this user that we want to liquidate, which is the wallet to liquidate in our .env file. We're going to bid super low today. When you're bidding, you don't need to bid them a lot unless you're competing for an actual liquidation. For this, I'm just using my own Oracle, so no one's going to bid against me. So a super low amount to bid. I want to update the API3 USD feed on this certain position. I've created all the ABIs here. I didn't import them, so you can read exactly which ABI I'm calling on which contract. I like people to show that, so you don't have to figure it out on a .abi like in import. So you can see exactly which ones I'm actually calling. So on our liquidator contract, that pay, bid, and update feed is what we're calling on our smart contract, right? On the lending pool, we're looking at the user account data. What is their position like? And we're calling liquidation. And then on the Oracle, we want to get the asset prices, right? We want to get the source of the asset to make sure that our Oracle prices are going to be compared to the actual oracles that we're looking at and what it's going to be in the future. And then we have a few functions, right? Get user data is basically what do we want to get the user account data of who we're going to liquidate, right? And so you'll see that it has a format. It'll have your total collateral and total debt, available borrowers if they have any, current liquidation threshold of what they have. So you can do the math ahead of time, right? Their loan to value right now, their health factor, and then I'm just kind of doing a 50% reduction because I know it's AVE max liquidation amount. So I'm doing the calculations ahead of time. So I know, okay, this person's going to get liquidated if I do it in 30 seconds, how much I can liquidate them for, right? And so it's just a simple function to get the user data. And then I actually go into details and calculate the max step that I can cover. So I want to make sure that within that user data function, right, that get user data, I calculate all this. I do some adjustments to scaling because Aave uses a return value of 10 to the 10 for their mathematics, so you don't overflow function. And then I start getting the values in USDC. So I just, multiply it with the scaling so I can see it like in USD values. And I commented it because it took me a while to figure this out myself, right? And then I want to make sure that it's 50% USD. So step-by-step comment on there, and I'm making sure that I have the decimal 6. So in a production one, you would check the decimal value of the token with an ERC20. Here, I know that USDC has 6 decimals, so I'm just hard coding 6 decimals for this case. But as a more advanced, and I can update this later, is you have an ERC20, check the decimal amount, and then return that value, and that's what the DEP token is going to be as well. And then I just log this out so you can see, exactly what you're getting. And then I want to make sure that I can liquidate, right? If the liquidation is invalid, just stop, right? Don't do anything, right? And then if they have no depth, don't error out on me. So I just have a few little things here. And then making sure that I have proper decimal places in case there's 6 decimals or 18 decimals. And then just more formatting more than anything. So that's basically what I'm doing. I'm calculating the max step to cover once I know the position. And then I'm calculating the projected health factor based on what I'm going to get in 30 seconds on that Oracle. Can I liquidate them, right? So I got to make sure that can I liquidate them now? Will they be close to liquidation? And then if I bid, is it worth it? So I got to calculate the projected health factor, which is basically the same thing based on the future 30-second value of the price feed. Will I be able to liquidate? And it's basically going to go through the same thing, and it's going to give me another say, hey, it's good. In our case, probably not, because the real Oracle versus the fake Oracle I have, it's going to give me a value saying, hey, probably not. But so we'll comment that out. And then here is standard OEV stuff. This is like the standard stuff of like determining the time count cutoff. That's on the OEV section of the liquidation. This is cookie cutter, get big topic. You don't really change this, get bid details. We don't change any. This is all the OEV stuff that you just kind of copy and paste, and you need this to do. The perform OEV liquidation is where we have our actual call to liquidate, right? And we're passing in our information. We won the bid, so we got our signature. We have the signed data cutoff, which we need to have for OEV, right? We have the price update details, which Oracle we're going to update, and then our liquidation parameters. Who are we liquidating? How much? What are we going to get back? Max step to cover, right? Then we call the liquidator contract, right, with all our liquidator, and then we have all our liquidation parameters right here, right? We have a collateral, debt, user to liquidate, and debt to cover, right? and then we're going to log that out. So we say, hey, this is what we're going to liquidate them for, so we know what it is. And then it literally just calls the pay, bid, and update feed with all the parameters, like all those details that we built up all together. We put it in a nice single package in the params with our signature, our awarded signature, how much we're willing to bid, and our details. That's what all gets encoded into that little piece. It just goes into the single pass, right? And then we make sure we pass the bid amount. Once we do that, it's going to give us the update. Hey, you did the liquidation perform. It does all the contract stuff, all the callbacks. That's all happening. Once it does, say, hey, we did it. We're good. We've updated the Oracle. We just go back and report the fulfillment. Hey, we did our job, right? Based on the transaction that we've done, on the bid details that were cookie cutter. We basically say, hey, we behaved. We updated the Oracle. Do not slash me on here, and we just report the fulfillment. This is similar to what we did on the last OEV, right? So hopefully this all makes sense, right? Of all these sub like functions that go, pretty much we calculate the liquidations, right? So here we just place the bid, right? We're just going to place the bid. We look at the lending pool. We look at the addresses, right? We fetch the OEV sign data, which is basically what is the price in the future. Here we want the price of the future for API3 USD, right? So we fetch that. We're going to calculate the projected health factor based on this price feed. Can I liquidate them or not? Is it worth it? It's going to let me know what the median price is. Here, I'm already commenting out because I know our position is not going to be liquidable because the actual price is not going to let me liquidate. But I would say, hey, if it's above 1, return, stop the script. It's not worth it. We're gonna try again at a later time because we can't liquidate, right? I've canceled that, so we know our position is going to be liquidable. Now we know who we're going to target. We're going to be targeting a Metis, right? And then we're going to look at the auction house. And we know that auction house is 4913. That's cookie cutter. You just copy and paste it. And then we start calling all our functions, right? How much time do we have? Do we have 30 seconds, 10 seconds to bid? Let's bid, right? And it's going to get the bid topic, which is all cookie cutter stuff that we need to know. The bid details, who's going to update the actual Oracle? That's going to be our Flashloan liquidator, the one that we deployed, right? So our Flashloan is going to do the update, and it's going to do all the magic behind the scenes. And it's going to just basically let us know the bid topic, the details, when we're doing this, and then when the next bidding phase is. If we don't get it, we just do the next bidding phase. We missed it, right? And all we do is actually place the bid with the expiration, and it has all the details, right? So we're placing the bid for the auction, and then it's just letting us know we placed our bid. And then it does the cookie cutter stuff of like encoding all our wallet information and everything that we do. We listen for the award. Did we win this? Did we win the bid or not? Right. So we won the bid. We're listening for that. It's just doing the callback here. So, hey, did we win? Oh, did we win? Okay, this is the signature we got for winning. Excellent. And then we're basically going to calculate our max bid to cover function. It's like, all right, we won the award. Let's, figure out how much we can liquidate off this person. It's going to let us know. And then I console log that out. This is how much we can go. We've built up those liquidation parameters because we know what we're going to receive, what we're going to repay, who we're going to liquidate, and then the max step we've already calculated. And then we actually call the perform OEV update and liquidation. And then with all the things we got our awarded signature, time frame, which we can do it, the price feed details that we have already, and the liquidation parameters. And once that all completes, then we report fulfillment, right? So perform OEV is that function all up here. So it's just basically step by step of everything that we've done, piece by piece. I know it's a lot to swallow. It's a lot of information on
Yeah,
there, but let's
you know
actually
what?
call it.
Since we were talking about AI agents and this,
Yeah.
one thing that I can certainly see value is
Yeah.
like having an AI agent in which I can ask things about this script. So I don't know
Oh,
if you have seen, but on Cookbook, you can have that functionality in which you open your smart contract and you have like an agent that you can ask.
yeah. Yeah. It's I've seen that. It's pretty cool. Yeah, I mean that's the beauty of forking it, right? You can see this code and it can take you step by
Yes.
step and go through it. Yeah. So yeah, I mean, if you can add AI as the off-chain agent of explaining, perfect use case in my opinion.
Yeah, so we have a bounty needy. Take note of this because
Yeah,
since we were working with Alit framework, this is
cool.
a nice use case. So, anyways, let sorry to
Let,
interrupt you, man.
yeah, no worries. That's perfect. Let's liquidate, right? Let's actually liquidate something. So like we have our supplies. I have this wallet here. I know the wallet. I know who I'm attacking, right? I'm set this up. I deposited these many tokens. This is my dollar value on what the current market rate is for API3. I've borrowed out, 49.10 USDC, right? This is my health factor. I'm dangerously close to being liquidated, right? So now in my database, I'm like, all right, this is cool. Right. So like I have this own little script that I made for myself, that I do to make sure that we can liquidate. And so it's just like a little thing here that I have. I'm just going to put this to the side here. And so I'm just going to run it. I'll make this bigger so you can see. Let me see. Can I do that without ruining this? Make it bigger. Yeah. Okay. And it's just a simple script that just calculates what that price would be. So my token quantity is 11,768 and 30, right? What's the token price? Let me go into the marketplace. Where is the marketplace? And find the price for API3 USDC. And so right now at its current price, it is 59.71. Not 59.71. And then liquidation threshold, I know is 0.75. And then the debt value, what is my debt value at? And that is 4910.45. 4910.45. So it's going to tell me that my liquidation price per token is 56 cents, right? So a price stop of 4 cents. So I know that if I have 56 cents on here, I'll get liquidated, right? So that was just a little calculation using that, liquidation parameter thing, that like the health factor liquidation parameters divided by debt. Just a simple formula on that. You could chat GPT that, or I could put it up if people really want it on here. So this update mock price in Oracle only works if you're the owner. So I'm going to update that Oracle to that right price, right? It was 56 cents. And so if I go to the top here, it's 54 cents. I'm just going to be safe and just put 55 cents on here. So I'm just going to go ahead and update that Oracle really quick. So we know that when I update my OEV feed and I update that I can liquidate. So let me go ahead and up that. I'm going to go ahead and update the Oracle. I'm basically updating my fake Oracle to 55 cents. So I know for sure that it goes. Oh, what happened here? What did I do here? Updating my price. I don't know. Let me do it again.
This is the beauty of light virtues, right?
Yeah, probably just like an RPC error or something. There we go. So it's updated my price for 50. So I updated my fake Oracle to do this, right? All right. So now I'm going to call this submit bid flash update liquidate. I know it's the worst name. It's super long. I have but I wanted to differentiate, like, okay, this is what this does. This is what this does. This is what this does. So you would call the submit bid because we're updating the bid. And then we want to flash loan and liquidate, right? So like I'm throwing all the names in that function. So I'm going to make this really big because it's going to go through the entire thing and we're going to see it here. So let's just go ahead and call it and move this over here. So it's fetching the OEV sign data for API 3. We're going to go through, I'll go through it piece by piece, right? So it's giving me the encoding. If you look at the docs, I already handle all the encoding for you of how it gets the data. So we know that the median price in the 30-second future is going to be 59 cents based on the real-time data, right? And so now I'm getting my position data, right? My total collateral is $7,026. My total debt is $49.10, right? My collateral price is right now 59. My current debt price is $1 USDC, right? This is how many collateral tokens I have, and this is how many debt tokens I have. And so with that new price, it would be this. And so the collateral value would be 742. So it actually go up in value, right? So like not good for me as a liquidator. So, and we know that liquidation threshold is this. So the projected health factor would actually be 107.55 after. So not a good liquidation for me either. But, now that I know that I can actually update and bid, I know that it's going to be like 55 cents, right? So I said position would be liquidable with the new price anyway, right? So then I'm going to place a bid on the OEV network. And this is cookie cutter. Bid topic and bid details are based on the values that I'm doing, right? With the current timestamp, because remember we have 30 seconds. And then that within that timestamp cutoff, we know we have up to this time to do so. And then the next bidding phase. So if I miss it, the next bidding phase is here. But most cases when it's liquidations, it's difficult. I'm probably lost it, right? So I placed the bid. This is my transaction hash. I'm listening for that bid award, right? I'm listening for the award. And so I got it. And so now I'm fetching the detailed user data and I'm calculating them again, right? This is the value in ETH, right? It gives you that weird value where it's 10 decimals, right? So it's 702, 7,026, right? This is 4910, right? So it has this weird, this is the values that you get when you eat it raw. That's why I converted over to this. So you can do more USD value and the health factor and all the details again. And then looking at the collateral asset, I know which it is, I know what the debt asset is, and the user to liquidate. So I'm just logging out all the information so you can follow along how much debt to cover. And so now it's performing the Oracle update and liquidation. It completed, it did all this stuff in the smart contract, went back and forth, swapped, paid back the loan. And now I've updated the Oracle, and then we're reporting to the Oracle that I actually did update and that I behaved, and then waiting for the confirmation of fulfillment. So then I didn't get slashed. So we actually updated in the Oracle. So let's go into the contract itself that we deployed on the liquidator. So let me go ahead and go to the deployments and minimize all this geriatrics. So I'm going to go to my Flash liquidator and then look at exactly everything that happened here. And it all happens that fast, right? Like I just explained it so it was like super slow. So it all happens within a block time, few seconds.
Yeah,
So I'm
all
going
of
here.
this code for something that the action just take place in just a few
Yeah,
seconds.
just
It's
seconds. Yeah.
incredible.
So you can see, like, if you go through the transaction, it goes through a whole bunch of stuff. It requests, all the money, how much I'm paying back, step by step, right? And how much money I'm borrowing. I'm actually paying back the 4902. You have mock tokens, so like it's going step by step. And I know we're out of time, so I'm going through this pretty quick of how much is being paid and payback loan. But at the end of the day, if I look at my tokens, I see that I am sitting on all this money available to me. So I've made this profit of this flash loan right here. I'm gonna see if I can make it bigger, but I'm sitting on this, whatever was left over for my flash loans, that's sitting in my contract waiting to be extracted, right? That's the net profit I got from paying back the loan, swapping the decks, earning money, paying back the flash loan, and then I'm left over with the profit, right? So depending on certain positions, how big the position is, you make more money on there. So if there's a $10 million position that's there ready to be liquidated, you can borrow it and make 5 to 10% off $10 million, right? I'm doing it with a couple thousand. So you can see why it's incentivized to actually make these large positions on flash loans on there. And nobody's sitting around with $10 million in their wallet. I can guarantee you that. So everybody's flash loaning it out and getting it all up and running. But that's essentially how it works on there. And then step by step for each one of these transactions. Everything is basically going back and forth with the callbacks. I'm paying back loans. I'm requesting this amount of money to borrow to pay back this loan. Remember, it's 50% of 492. So in 2045, so all that is going back and forth. I have a detailed analysis on the previous liquidation workshop where I go step by step of each one and explain which going back and forth. But you can see like the mock API3, ERC20 is the USDC. So how much I'm getting back, how much I'm getting back for the swap, what's happening in the swap beforehand. So all that is kind of detailed in the previous workshop as well. But yes, that is like a lot of information to swallow on there. So that's why we did it step by step by step by step, because if I came with this workshop first, you'd be like, what? So, and then at the end of the day, I paid back my bid amount, right? I had to pay my bid amount in order to make this all happen, right? But with that kind of profit at the end of the day, I'm cool with it, right? So,
Of course.
yeah.
I mean,
Yeah.
the grind never stops,
Yeah.
but you made it all work
Yeah.
with that demonstration there, right? So
Yeah.
it's clear why people are incentivized to pursue this despite the complexity. So
Yeah.
thank you so much,
Yeah.
Billy Jitsu, for sharing all of these workshops with us. I'm very, very grateful for this. The I think we're going to be creating some more material actually after this so that we can explain more things to new developers so that they can get started with this.
Yeah.
And we're going to be sharing, obviously, the resources as well with the GitHub links. And yeah, I think that for the people that were asking about the Alit bounty, I don't know if you know, Billy, but we have like this AI agent framework on Metis, which is actually developed by another company that we are incubating called it Last AI, and we have a bounty to kind of use this AI agent framework. So I think that one possible use is actually utilizing this to kind of help developers explain what is going on with all of the repositories that we have running for these liquidations, and it could be an interesting use case. But yeah, we will see. We will see. Certainly, this is a lot of material to cover if we are just getting started. So just one final question. I know that you probably have to go, but how much time more or less you would estimate that if I'm a newbie, I mean, I know a little bit of Solidity and whatnot. I'm just testing the waters. How much time should I invest in order to cover all of these topics on a more deep way?
Well, minimum 7 hours just on the workshops alone, right?
Exactly. Yeah,
So,
that's a
I
good
mean,
one.
but you really have to use DeFi, right? Like you have to deposit and borrow, and that's why I think I
Mm,
really like using the Aave fork, because you don't have to use real money to learn, right? Instead
yeah,
of running simulations, you can actually do it. You're not searching for testnet tokens. You're not doing. You make your own testnet tokens that work on there, and if a testnet goes down, you don't have to like, oh, now I don't know where to go to mess with it, right? You control where you can deploy it, so it makes it super super easy. But using a little bit of real money, you pay a lot of attention, right? $100 you deposit somewhere and you borrow, you know what it's like to be like, oh, I'm close to liquidation, I can't sleep. So you
yeah,
understand the flow and how fast
yeah,
things go. Yeah. So I would say I've put, at least in essence for myself, probably over 400 hours in learning this stuff, understanding this stuff, and getting there, and then coding for it, hours to get this, not to just make it work, but to get it to a point where you can explain it, right? Instead of being it the most efficient way, I got it to be the most way where you can follow it and flow with it, because there's a lot of steps, right? Like it's just nonstop of like, oh, here's a flash one. And that's why a lot of tutorials stop at, okay, you got your flash one, and then that's it. Because once you get past the next step, there's so many steps to go next that actually makes sense. So you have to learn, learn how to, like when I started learning Solidity and I wanted to make a website, I didn't want to learn how to use JavaScript, but I had to. But then I had to learn how to use React. And so, okay. But then I have to learn how to use CSS. I'm like, okay. And then I had to learn how to use HTML. Like, wow. So like I had to learn all these subsections first in order to get my website. But I just wanted people to use my smart contract, right? So
Yeah.
that's the same way it works with DeFi. You have to learn all the parts of it, the swapping, the leveraging, the oracles, the transaction times, the block times. You need to learn all those different things. And that's why in each workshop I try to cover one extra skill, so therefore you
yeah.
have the skill set in order to do this final workshop. For someone that's coming into this final workshop, it's overwhelming, right? Even for the guys that have been following along, it's kind of overwhelming. You have to spend the time to sit there and like go through the code. So if you watch the video and go through the readme and then have it side by side and take it at your own time to absorb, I think you'll be able to get it. So if you're watching videos alone, minimum 20 hours.
Right,
Yeah, yeah,
right. Yeah, but I think it is worth investing the time in learning this kind of thing because I'm telling you, this is not a common material that you can find
yeah,
to learn like proper DeFi in blockchain. So, anyways, Nidhi, do you have any final questions for Billy, Jitsu, or something else you wanted to share?
Not a question, but I really appreciate that we have been doing like a lot of workshops with the API 3, and we do all have listed all the workshops on the YouTube, and also is available on the Twitter on the both of the account. But finding on the YouTube will be more easier, I guess. So I'll recommend all the viewers. Whoever watching right now, if you don't have like seen the previous ones, please go check out all the previous ones, which is like really helpful and interesting and hands-on experience Billy has uh, given on that particular workshop. So, and also let us know if you have any questions, query regarding anything like API 3 or in any integrations. We are always available on the
yeah.
Twitter and on the Telegram group chat.
Yeah, yeah. I mean, given the time with the crazy moments since
Yeah.
February and we were getting mass liquidations, our dApps have been happy. So, because there's so many liquidations happening and people longing or shorting certain stuff, that like the dApps that are actually using us are quite happy with the results, because when most people are getting nothing out of it, they're getting something because they're getting that bid value. So
Yeah.
been pretty good, pretty good. And then
Yeah.
if there's other materials or any kind of workshops that you need, let me know. API 3 is available for you. We can go dynamic, right? So we
Yeah.
can do all kinds of things for future. Yeah.
Yeah, I would like to whoever is watching, like feel free to drop any feedback, like or anything that we would like to see this in the next workshop. We would be definitely happily, organizing it and
Yeah. Cool. The baby
Absolutely,
agrees.
guys. The baby race. All right. Thank you. Thank you so much, Billy Jitsu, API 3, the people that are watching right now. Please make sure to subscribe, ask as many questions as you may have, and we will catch you up soon. And if you have any questions about this other thing that we're running with Alit, please feel free to send me a DM. I'm always available. So thank you so much, guys. I'll see you on the next one.
thank you so
Love
much,
you guys.
guys. See you on the next one. Bye.
See
Bye
ya.
bye.